Hey guys, I'm making you this video of the problems of the day that we were going to complete today since I won't be in class due to testing. So that way you have something to reference and you'll be able to review before you complete your Edulastic assignment. So we're going to review here how to graph our rational functions based on how it's written. For A, we noticed that the rational function is already written in transformation form. So we're going to identify what are the asymptotes and then write out the transformation rule. The vertical asymptote is always the number that is added or subtracted to the x, but the opposite sign. So we have a vertical asymptote at x is equal to 2. Our horizontal asymptote is the number that is added or subtracted at the end. So we have a horizontal asymptote at y is equal to 1. Now we're ready to write out the rule. So we have xy. Our rule for the x's is anything that is in the denominator, but of course the opposite operation. So instead of dividing by 3, which is this 1/3, we multiply by 3, and then we add the 2. So 3x plus 2. The rule for the y's is anything that is outside of this parenthesis of the fraction here. So we have the negative and then plus 1. So the rule for the y's would be negative y plus 1. Our reference points for the rational function is -1, -1, and 1, 1. So we're going to plug in those points into our rules to get our new coordinates. When we plug in -1, -1, 3 times -1 is -3, plus 2, -1. When we plug in -1 here, we get -1, which becomes +1, plus 1, so 2. Now when we plug in 1, 1, 3 times 1 is 3, plus 2 is 5. Then -1 plus 1 is 0. So we have our asymptotes, we have our points, we're ready to put this on the graph. So we have the vertical at x is equal to 2. We have the horizontal at y is equal to 1. And now we're going to plug in those points. So -1, 2, and 5, 0. And based on where those points lie, we're going to curve according to my asymptotes. So this would be my graph. Now remember that the domain and range is affected by your asymptotes. The domain is all x's except for my excluded value, which is x is equal to 2. So my domain is going to be -infinity to 2, union 2 to infinity. The range is all of the y values except for where we have the horizontal asymptote, since that is what would be excluded from the range. So the range would be -infinity to 1, union 1 to infinity. Now in this next example, we have 3x plus 4 over x plus 2. This is not written in transformation form, so we have to rewrite it so that I can see what those transformations are. So we're going to do the division that it says to do. This means 3x plus 4 divided by x plus 2. So that means that we're going to put the 3x plus 4 inside of my division symbol and the x plus 2 on the outside. As a reminder, when we're dividing, you look at what we need to multiply x in order to get 3x, which would be 3. And now we distribute this 3. 3 times x is 3x, and 3 times 2 is +6. Now we switch the signs. The 3x's will cancel, and 4 minus 6 is -2. Now when we're writing our answer, we always write what we got, so 3. Then we add the remainder, which is -2, and put it over what we divided by, which is x plus 2. Now this is starting to look better, but it's not quite right yet. We always have the fraction first and then the number at the end, so we're just going to reverse the order. This is the same thing as saying -2 over x plus 2, and then since the 3 is positive, we put plus 3. Now again, almost there, but the numerator should just be 1. So whatever is in the numerator, we're going to put it outside of the fraction. So this is now written as -2 parentheses 1 over x plus 2, and then the plus 3. Now this is in transformation form, and I can now figure out my asymptotes and my rules. My vertical asymptote would be at x is equal to -2. And my horizontal asymptote is at y is equal to 3 because of this plus 3 here. Now we're going to write out our rules. The rule for the x's would be the opposite of what it says in the denominator, so x minus 2. The rule for the y's is anything outside of the fraction, so we have this -2, so -2y, and then plus 3. We have our reference points, which are -1, -1, and 1, 1. Plug them in. -1, -1, when we plug it in, we get -1 minus 2, which is -3. -2 times -1 is +2, plus 3 is 5. Now when we plug in 1, 1, 1 minus 2 is -1. -2 times 1 is -2, plus 3 is 1. So we have our asymptotes, we have the coordinates. We're going to put all of this on the graph. So we have the vertical at x is equal to -2, the horizontal asymptote at y is equal to 3. We're going to go ahead and plot those points, -3, 5, and -1, 1. And now we curve according to those asymptotes. And that would be my graph. Now my domain is affected by the vertical asymptote. It's all real numbers except for x is equal to -2. So my domain would be -infinity to -2 union -2 to infinity. My range is all real numbers except for when y is equal to 3. So my range is going to be from -infinity to 3 union 3 to infinity. Now the last bit I want to review is how to write out the equation of a rational function based on the graph. As a reminder, this is the general form of a rational function. So in order to write out the equation, we first need to identify the values of h and k, which is determined by the vertical asymptote and the horizontal asymptote. We have the vertical asymptote at x is equal to -3. And we have the horizontal asymptote at y is equal to 1. So now I'm going to write out my equation, replacing h with -3 and k with 1. So g of x is going to equal to a times 1 over x minus -3, so x plus 3, plus k, which is 1. Now you're going to pick either point. It does not matter which one you choose. I'm going to choose -2, 3. So that means that x is -2 and 3 is g of x. And now I plug this into my general equation here. So 3 is equal to a times 1 over -2 plus 3 plus 1. We can simplify what's in here. So 3 is equal to a times 1 over -2 plus 3, which is 1, plus 1. And 1 divided by 1 is just 1. So this is the same thing as saying 3 is equal to a plus 1. So to solve for a, we would just subtract the 1. So we get a value of a is equal to 2. Now that I know a, I can go back to my equation here and plug it in. So my final answer is g of x is equal to 2 parentheses 1 over x plus 3 plus 1. and that would be the equation for that rational function. Now that we've reviewed, you are ready to work on your Edulastic assignment.